Good morning. I'm Dr. Sanjay Jain, Associate Professor in Mathematics, SPC Government College Ajmer. As earlier, we are studying in Continuum Mechanics the transformation law of Cartesian tensor. Today, we are going ahead with it. We are taking today conical delta new type of a tensor, which we already studied in previous in tensor calculus. You are going to conical I in superscript and subscript j other indices, that is called mixed tensor, conical ij in superscript or conical ij in lower script also. Here we are taking an index notation conical ij, that having two values 1 and 0 when I is equals to j, and when I is not equal to 0 when I is not equal to j. What is the role of that Cartesian tensor conical I delta? This may change the indices. For example, we are seeing here AI is nothing but conical ij aj. I changed to j. So conical ij is used to change the indices. Whenever we need, we can take conical ij. When I is equals to j, it take the value 1. So I can be written in the j form. So it is used when the indices may be changed from different to. If we want to change from R to S, then we use conical RS. Okay. So conical I is nothing but AI is AI dash from prime unprime to conical ij aj primed axis. Okay, this is in a simple relation or transformation law of order of tensor of order 1 we already seen. Okay, transforming the left hand side means the ai dash. From transformation law we can write a I j asi aj dash is equals to conical ij aj. Simple meaning is we can open AI with using the AI is not from the prime axis, so it goes to unprime axis. Okay, simple relation ASI AS change to conical IJ AJ. So this is an left hand side of this can be taken 1.12 is same, or in left hand side we use the transformation law. Okay, now again in that equation a I dash may written again from prime to unprime here. So we again use this by transformation law ASI ASJ AJ is equals to conical IJ AJ. Okay. So now both the value of both AI is in the same axis, either in prime or in unprime. So we may taking these all in the one sided. So when we taking this side and taking common AJ, okay. So after taking AJ common, we get ASI and ASJ minus A conical IJ AJ equals to 0. This equation become this one, where the components, what is the components ASI and ASJ of an arbitrary vector, and the terms in the are independent from AJ. That's why independent from AJ means AJ can't be 0, so remaining should be 0. When we using this, we get ASI and ASJ is nothing but conical IJ. Okay, so one indices in A's are same S and S, so remaining are IJ becomes conical IJ. What we can write if we change these, ASI can written AIS and ASJ can written AJS. We can also get this by using the same way. So we get conical IJ. What is these two last equation shows? IJ position of IJ and S may be change. Okay, so this may leads a very important law. What this important? These equations are well known orthogonal conditions of that the direction cosine. What is small a is our direction cosine. So equation 1.13 and 1.14 are the well known orthogonal condition that the direction cosine between the two set of Cartesian axes must satisfied. Okay, so this may follows from conical ij. So this is a conical ij tensor which may use to change the indices from I to j. If we take conical RS, then from R to S, we always using this, and we earlier studied in previous in the paper of tensor analysis. Okay, next we are taking these. Yeah, this one. First we are taking appropriate set down of transformation laws for a Cartesian tensor of order n. Here we note that tensor of order 0 means scalar. Tensor of order 0 is scalar. So when we write a scalar quantity A in prime axis or this scalar quantity in unprime is are the same. So A is equals to A dash. Either in prime or in unprime, scalar quantities are same. So that's why A is A dash. But when we use the tensor of order 1, it transform. We already seen in the our earlier lecture the transformation law. So A R dash, order of first tensor, is nothing but direction cosine ARS, small ARS. R is the same. Next one is if I, sorry, there is ARI. So the vector AI we get from unprime to prime. So this become first order tensor laws, transformation law by transformation law. AR dash is nothing but ARI AI. Dash is unprime and without dash prime. Or if we extend these rule, order 1 की जगह, in place of order 1 we take more order, that is A dash R S T and so on. So the first indices with small ai's, there is R S T. We are saying either three components A, in which first indices are R, in second A first indices is S, in third A first indices is T, RST, and the second indices are I, J, K. So A dash RST in unprime change to A I, J, K in prime. So this is a transformation law. If we take it is of order 3, so we have 3 components. So but in case of n, they have n components. Okay, these are defined like this: Aijk component of Cartesian tensor of order n in an unprime Cartesian system. But in dash system, component of the same Cartesian tensor in the prime system, and small aij are the direction cosine. So therefore, this is an important, the transformation law of a tensor of order 2 is, this is an of order 1 vector law, second for transformation law second order. So we have two component of aij here, ar dash. So first component of a becomes r, and for second a first component become s, first indices become s. If we take second indices I in first a and j in second a, then this change to aij from prime to unprime. So ars dash is nothing but equal to ars a sj aij. Okay, so this is a second law, transformation law. From the point of view, we denoted for a certain order. This is for second order. Third order we need 3 component, and for n order we need n component of AIs. Okay. After that, you have already studied The addition, subtraction of two tensor is again a tensor of the same order. So here in Cartesian system, the same rule as it is. Two Cartesian tensor of same order, if we added these, we get the same order tensor Cartesian. If we subtract the same order tensor, we get after subtracting. Okay, these we already studied in tensor calculus previous. Now here one more thing we are studied. The Cartesian tensor can be denoted by two convention, and these are known as first one is range convention, second is known as summation convention. So first we want to know what is the difference between range convention and summation convention. So in very first line we are seeing whenever a small Latin letter subscripted occur, that is in a very important, occurs unrepeated in in a term, it is understood to take on the values of 1, 2, 3 and so on unless state otherwise. जब तक हमको कहा नहीं गया हो, जब तक आपकी अनरिपीटेड वैल्यूज रिवाइज होंगी, द सच सिस्टम ऑफ दिस इज नोन एज रेंज कन्वेंशन. फॉर एग्जाम्पल हेयर वी टेक ए आई, one index is here, it may a1, a2, a3, these are unrepeated. Okay, so here symbol we also uses, already we have studied in the first lecture. A is nothing but tensor of order 0, that is known as a scalar. AI is tensor of first order, that is called vector. Aij is tensor of second order, that is called matrix. Aijk is tensor of third order, and Aijkl is tensor of order 4. And one more rule is there, and so on. We can write as we know, as we wanted to order of n. So it may extend up to Ijklmn till we get n order. In 3 space, a tensor of order n has 3 की power n component. For instance, it's simple, we are taking an example Aij. Aij is nothing but expressed as like this matrix. Aij in 3 dimension. So we have 3 dimension and indices are there 2ij. So 3 की power 2, that is 9 components. So in Aij we get 9 components, that are A11, A12, A13, A21, A22, A23, A31, A32, A33. So these are 9 component. So in case of range convention, we need subscript unrepeatedly. And opposite to that, we have summation convention. This is summation convention. The second important rule in the summation convention, wherever a small Latin letter subscript occur repeatedly, they are repeated. This may repeated. So this is the difference between range convention and summation convention. In range convention, it is unrepeated. In summation convention, it is repeated. In a terms, it is understood to represent a summation convention or range of 1, 2, 3 unless state otherwise. It may be unrepeated. Okay, so this is the difference between range and summation convention. One more thing which you have earlier studied, that all suffixes in the text will be written as subscript. In index notation or Cartesian tensor, we have all the notation, all the indices are subscript. But in tensor calculus, you have already studied, in which you have a superscript, you have a subscript, or sometimes you have subscript as well as superscript, which is mixed tensor. Okay, so you have contravariant tensor, covariant tensor, or mixed tensor. But in whenever we refer Cartesian tensor, we have a lower subscript only. Okay, this is the notation of Cartesian tensor. In place of Cartesian or covariant or contravariant, we have only one indices, that is in lower subscript. So this is the simple representation of
tensor, and some rule of addition subtraction are same as we earlier studied. So today we have taken these rules studied till now, and next in our next lecture we are taking the product may be scalar, product may be dot product of two vector or tensors. In the next lecture we are taken it. So for today, the summation, range convention, addition, subtraction, and conical delta. Today we have discussed this. You may revise it, and for next lecture, thank you.